Okay, our next section is section 9.1, and we're going to talk about infinite series. So in our last videos, we talked about sequences, which are often infinite in length. And now we're going to take those sequences of numbers and we're going to sum those up as we go along, and we now call them an infinite series. When we want to write an infinite series, we use the Greek letter sigma. And the typical notation is that you have an index n, and you tell the world where the index starts. So n is the index. We're just using it to keep count of where we're at in the series, the index. And it starts at 1 and goes to infinity. Now in some cases we may start our index somewhere other than 1 if we need to, and that's perfectly okay. We manipulate that to make finding the sum easier when we need to. All right, and each term is then known as the a sub n term, and so we would write the sum from 1 to infinity of the a sub n's. And if we wanted to list out the terms, they would look something like this. a1, the first term, plus a2, the second term, plus a sub 3, the third term, and we could continue that on as far as we needed to go. So this is a common way that we would represent the basic sequence of terms that form an infinite series using that general nomenclature. So much like working with an infinite sequence, we like to find an expression that describes what each term a sub n looks like. So as an example, I might write from n equals 1 to infinity of 1 over n. So my a sub n is now 1 over n. Each term is going to look like 1 over n, where n gets replaced by the index depending on where we're at in the series. So if I wrote these terms out, it would look like this: 1 over 1, because that's my first term, so n is 1, I get a 1 right there. Now my second term, where n is 2, I'm going to have 1 over 2. My third term, 1 over 3. And I could keep writing those out however far I needed to go. Okay, so this is how we would identify the a sub nth term. If I needed to know the 20th term, I could use this definition of the a sub nth term to write the 20th term if that was helpful. So one of the things that we often do when we're working with an infinite series, we often want to know, what is the sum? What's the total? When we add up all that infinite number of values, what value do we get? Does the sum converge? Does it go towards a finite value? Or does it diverge, goes off to some infinitely large value, or maybe it fluctuates between values? So we want to find that out. And one of the ways we can explore that idea is to use what are called the partial sums. So let's look at the partial sums, or a few of them anyway, of this series that we've just described right up here. Okay? So the way that we note the partial sums is we would use the letter S with a subscript that says how many terms we want to have in our partial sum. And so if I wrote S sub 1, that would be the first partial sum. And so I would use the first one term, and I would total those up. So the first partial sum, the sum of the first term, would be 1. The second partial sum, I would use the first two terms. So I would use 1 over 1 plus 1 over 2. Now if you don't like writing 1 over 1, you can certainly just use 1. That's not a problem. I usually write it this way because that's often helping me to recognize the pattern. Sometimes when you start with a 1 and then you go off into some fractions, the pattern can be harder to sort out. And I want to be able to identify the pattern that's happening here as much as anything. So here's the second partial sum. 1 over 1 plus 1 half. 1 plus 1 half, that's going to be 3 halves. The second partial sum is 3 halves. Third partial sum, It's going to be the first three terms. So 1 over 1 plus 1/2 plus 1/3. So that's 1.5 plus 1/3. 3/2 plus 1/3. So that's going to be 9/6 plus 2/6, 11/6. Okay, these are our partial sums, and we could continue on, fourth partial sum and so on, as many as we need to make, depending on our situation. And what we're sometimes interested in is what's the limit of the partial sums as n goes towards infinity. So we sometimes might track the partial sums and see where they're headed to help us find if the infinite series is going to converge. Okay, so that's the basic idea behind an infinite series. We've got our a sub nth term. We get summed up from n equals 1 to infinity, and then we can write out those individual terms, and we sometimes are interested in partial sums. First partial sum, second partial sum, and so on. Okay, so we'll come back in a new video. We'll take a look at some examples of infinite series. Thank you.